All right, now we come to chapter 11 on present value problems versus what we just were working on, which is compound interest problems. And what present value problems are is basically I know what I want in the future. So what do I need today? What do I need presently in order to have that in the future based off of different terms? So this may be a good type of problem. Like, let's just say that you want to buy a brand new car and it's going to be $50,000 and you're planning on buying it in 5 years. So you need to know, how much do I need to invest right now in order to have the $50,000 I need in 5 years? So I know the future value, I don't know the present amount. And the present amount, by the way, is always going to be less than the future amount. Always, right? Because it's what you had before you got interest over time. And so it's always going to be less than your future value. So if you look at the problem, and you can see the example I give right here, you have your future amount, but you don't know your present amount. I know I want 50K in the future. So what do I need today in order to have that based off of the rate and the time? And so that's what we're going to be figuring out. And the good news is you actually solve these exactly the same way as you solve the compound interest problems. The only difference is you use a different chart. And that's what I did a minute ago on the other video. Is I went to the wrong chart. I went to the present value chart, not the future value or compound interest chart. So chart 11.1 is for compound interest. Chart 11.2 is for present value problems. So our work went out here and it'll hopefully make more sense. It says Count Gustavo wants to renovate a castle in Bologna in 3 years. He estimates the cost to be $3 million. So he's saying 3 years from now, I need $3 million. Use table 11.2 to find out how much Gustavo must invest now at 8% compounded quarterly to have $3 million in 3 years. So what I'm trying to find out is, how much do I need now? What is the present value of $3 million in 3 years? So that's what I'm going to solve for. So just like I did for compound interest, I need to first find out how many times is it going to compound and what interest rate each time it compounds. And it's done exactly the same way. It says here that it's going to be compounded quarterly for 3 years, right? So 3 years times 4, because it's 4 times a year, means it's going to compound 12 times. And then the interest rate is going to be compounded 4 times per year. 8% at 4 times per year equals 2%. So it's going to compound 12 times at 2%. Well, in this case, I'm going to go to table 11.2, and I'll show you that here in a minute. But table 11.2 is also found on page 355 of your book. And if I come down to 12 periods at 2%, my table factor is 0.7849. Notice it's less than 1, and that's because it is going to be a lower value. And so I'm going to multiply my principal amount, or my amount that I'm hoping to have in the future, 3 million, by that factor. So 3 million times 0.78849 equals $2,365,470. So I need to invest today. So this is the present value. $2,365,470 is the present value of $3 million in 3 years. So if I invested that $2,365,000 now at 8% interest compounded quarterly, I will have $3 million at the end of those 3 years. So that's all I did, was I found the present value of some future value. And in this case, the future value of 3 million was 2,360,000, or present value of 3 million in the future 3 years from now was $2,365,470. So that's how you solve these problems. Exactly the same. You're just using a different chart, using chart 11.2. And I'll show you that chart real quick here, just so you can see the difference. It's exactly the same, but it does say present value table. And again, in that case, we just use the 12 years and the 2%, and we got the 0.78849, and that's what we use to multiply by the future amount that we're hoping to have, and that gave us the present value of what we needed. So I'm going to go back to that. So we have a few problems down here, doing kind of the same thing as we did before. We have a principal of 6,000. We have 3 years at 9% interest, compounded annually. And so in that case, it would compound 3 times, and it would be 9% each time, right? Because it's annually, so it's just once a year. So if I took that, found the table factor for that, 3 at 9%, and 9% is on the next chart, comes out to 0.7221 or 77218. So 0.77218. If I multiply that by my 6,000 that I'm hoping to have in 3 years, it's going to give me, it should give me exactly what it says there, 0.72218 times 6,000 equals $4,633.08. That's how much money I need presently in order to have 6,000 in 3 years at 9% interest compounded annually. How much interest did I earn? Well, again, I would take my 6,000 that I'm going to have and minus the 4633.08 I presently need to have. That means I will make $1,366.92 of interest. So the compounded interest is the present value subtracted from the original principal that you're, or the present value just minus from the future value you hope to have. And when it says principal here in this particular one, it really means future value. All right, same thing here. 6 years compounded of 4% compounded semi-annual. That's 2 times a year, so that means 12 times, and then that would be 2% each time. So 12 and 2 would be a table factor of one we already saw, 0.78849. If I multiply my future value of 24,000 times 0.78849, that equals a total present value of 18,923.76. So 24,000 is what I'm hoping to have in 6 years. So that means presently I need to deposit 18,923. And if I want to figure out how much interest that loan would earn, I would take my 24,000, which is what I'm hoping to have in the future, sorry. And I would minus the 18,923.76. And it would come out to $5,076.24. So there's my compounded amount. I made $5,000 on that investment. Again, 5 years at 8%, compounded quarterly. So 5 times 4 is 20 times. 8 divided by 4 is 2. So 20 periods at 2%. I'd go to the table. 20 periods, 2%. Table factors 0.67297. I would do the math, multiply 650 by that. That would tell you what I need presently, and then I would subtract the difference to find out what my compound interest is. Now, again, same exact thing here as you're doing on all the other problems. The only difference is you're using a different chart, and your values are always going to be lower than your, in this case, principal or future value amount that you're hoping to have in the future. Now, you might say, well, how do I know whether I'm doing a future value problem or I'm doing a present value problem? Well, it'll either say it right in the problem, present, what is the present value or what is the compound amount, or it's telling you how much you're going to need in the future. So they're asking you, what are you going to need today? And that means present value. What do you need presently in order to have that value or amount in the future? So that's the best way to determine it. Also, sometimes it does tell you which table to go to. So if it says to go to table 11.2, then you know it's a present value problem. If it tells you to go to table 11.1, you know it's a compound interest problem. So I'll just say this, the best way to determine what kind of problem you're solving for is if it says anything about ordinary interest or exact interest, you automatically know that's a simple interest problem and you don't need any tables. You can just use the triangular formula with interest divided by principal times rate times time, and you can solve those problems. If it says anything about a future amount that you know you have today, you know what it is, and they're looking for what you would need now or today, then you know it's a present value problem. If you know what you have today, but you don't know what you're going to have in the future, that's a future value or compound interest problem. And that's the best way to determine which one you're solving for if you get confused. So, all right, we're on page 7. So this is a few more. I just kept going with that. I'm gonna just do these last few on the bottom of this page. Excuse me. It says how much must be invested at 6% today to have 8,000 in 3 years. So again, compounded quarterly. So if I have 3 years, that means times 4, because it's going to be compounded 4 times each year. So that's 12 times, and it's 6% is how many times per year. So I'm going to divide that by 4. That's going to come out to 1.5%. So if I go to my table, 11.2, I go 12, 1.5%, comes out to 0.83639. If I multiply that by my 8,000, 8,000 times 0.8369. Oops, I didn't type it right. 0.83639 times 8,000 comes out to I need $6,691.12. So what's that saying? I need to invest $6,691.12 today in order to have 8,000 in 3 years. So that's how I solved it, right? TriStar Airlines intends to pay off a $20 million corporate bond issue that comes due in 4 years. So they're going to pay it off. How much must the company set aside now? So they're looking for the now at 6% interest compounded monthly to accumulate a required amount of money. So 4 years times 12 means 48 times, right? 6% divided by 12 equals 1.5%. Okay, so I'm going to go to my table and look for 48.5. And guess what? It's not going to be there because this only goes up to 25. So I'm going to use 24 times, so twice, 0.88719 times 0.88719. Remember, this is for the first 24. That's for the second 24. They're both at 0.5%. I do the math on that. 0.88719 times 0.88719 equals a new table factor of 0.787106096. I'm going to multiply that by my 20 million equals 15,742,121.92. So what's that saying? My present value of $20 million in 4 years at 6% interest is present value is 15,742,000. How much interest would I earn? Well, if I just subtract that from 20 million, it is a $425,787 difference. Is that right? Yeah, $425,787 roughly. That's how much interest I would have earned over those 4 years. Pretty incredible, huh? Last one. Stuart Daniels estimates he needs $25,000 to set up a business in 7 years. How much must Stuart invest now? How much compound interest will he earn? It's kind of the same problems that we've been doing. So 7 years compounded quarterly. So 7 times 4 equals, what do we say? 28. Again, we have the same problem here with not enough periods on the chart. 8% divided by 4 equals 2%. So we're going to do, we're going to do 14 at 2%. What is the table factor for that? 14 at 2% is 0.75788. That's for the second 14. So I'm going to multiply those two together. 0.75788 times 0.75788 equals 0.574382094. Multiply that by the 25,000. That means that I need to have $14,359.55. That's how much I need to have now to invest. The present value of the 25,000 in 7 years is 14,000. So how much then compound interest will I earn? Well, I just need to subtract that from the 25,000. I will have earned $10,640 of interest. Pretty nice, huh? That's because it's 8%. You can't get that anywhere now. You might be able to, I guess. So that's compound and present value, compound interest and present value problems. This is specifically present value. I think the last page I had to look at was simply the compound interest chart for. I do have one more problem there. Summertime songbird population with the Mid-America flyway is predicted to increase over the next 8 years to a rate of 2%. The songbird population reached 55 million in 8 years. How many songbirds are there today? So again, let's see, it's increased next 8 years at 2% per year. So it's going to be 8. So the table factor is going to be 8 times and 2%. So if I look at 8, 2%, so it's 0.85349 times 55 million. So that's going to tell me how many songbirds there are today. So 55 million times 0.85349 equals. So they have today 46,941,950. That's songbirds today. So they have 46 million today, but they're going to have 55 million in 8 years from now because there's a 2% growth each year. And that's solving present value problems. So that's pretty much it for this video. Hopefully this helps if you follow what I have described in solving these problems. You should have no trouble completing the quiz and or the exam, as well as the check-in assignment. My recommendation is to make sure you do the quiz first, get my feedback on that, then do the check-in assignment, get my feedback on that, and then do your exam this week. So have a great week, everybody, and thanks for joining me on this session. And if you guys have any questions, please let